fasilitas yang memadai. Program studi teknik mesin memiliki fasilitas seperti ruang kelas, perpustakaan dengan akses ke berbagai jurnal ilmiah, ruang diskusi, emergency exit, auditorium, ruang kegiatan mahasiswa.
Selama proses pembelajaran di teknik mesin untar ini, saya mendapatkan banyak ilmu pengetahuan dan berbagai fasilitas yang lengkap, serta ada kegiatan workshop seperti go-kart dan mobil irit.
Program studi teknik mesin memiliki laboratorium, yaitu Laboratorium Proses Produksi, Laboratorium CNC, Laboratorium Mekatronika, Laboratorium Prestasi Mesin, Laboratorium Fenomena Dasar Mesin, Laboratorium Metalurgi Fisik, Laboratorium Hidrolik dan Pneumatik, Laboratorium Perpindahan Panas dan Massa, Laboratorium CAD/CAM, Laboratorium Teknik Tenaga Listrik,
menjadi lulusan teknik mesin di Universitas Tarumanegara mampu membuat saya bekerja sesuai dengan passion saya. Bahkan saya mendapat pekerjaan pertama saya sebelum wisuda. Teknik mesin Universitas Tarumanegara memberikan kita peluang karir yang bagus, terutama di bidang industri-industri besar dan dalam waktu yang singkat. Pengetahuan yang saya dapatkan seperti perpindahan kalor dan massa, air mesin, serta berbagai kegiatan akademik dan kemahasiswaan mendukung pekerjaan saya saat ini sebagai seorang engineer.
Dibuktikan dengan rangkaian prestasi dosen dan mahasiswa berperan aktif dalam kejuaraan nasional dan internasional. Dosen program studi teknik mesin Universitas Tarumanegara juga aktif dalam melaksanakan tridharma perguruan tinggi, yaitu pengajaran, penelitian, dan pengabdian kepada masyarakat. Program studi teknik mesin juga memiliki beberapa kerjasama nasional dan internasional. Program studi teknik mesin Universitas Tarumanegara, Creating Innovative and Professional Mechanical Engineers.
Good morning, ladies and gentlemen. Before starting this conference, please allow us to inform the following information. Rules for participants in the plenary session, ICMIEE 2021.
Participants enter the Zoom meeting in the plenary session at 9 a.m. GMT +7 or Jakarta time.
For paper presenters, please type their names when registering the Zoom meeting using the format Zoom room, paper ID, name. For example, ICMIE1-000-Zendo.
For participants, please type their names when registering the Zoom meeting using the format institution-name. For example, Untar-Jondo.
For participants and paper presenters, please be kind to fulfill the attendance form using the Google Form link, which will be provided in the Zoom meeting chat room during the plenary session.
Participants are required to fill the plenary session evaluation form, which also be provided in the Zoom meetings chat room in order to acquire the e-certificate as participants.
For participants who want to ask questions to the keynote speakers, can type the question using the application of Slido.com by entering the code number 242424, or please scan the QR code shown in the screen or simply using the link shown in the screen.
Slido application can be visited using any device from the search engines by typing slido.com.
Then please enter the code number 242424 in the column shown in the website or simply scan the QR code shown in the video.
You will be delivered to the ICMIEE Q&A room, and you may type a question you want to ask the keynote speaker.
Every question that are delivered will be shown on the room, so you can see other people's questions from your device.
You may also give a thumbs up if you like one of the questions.
The question with the most likes will be shown at the top of the page.
At the Q&A session, the moderator will read the question starting from the top of the page.
So, please make sure to select the question that you would like to ask the keynote speaker.
For rules number 7, participants are required to turn off the microphone during the conference, or else the organizer will switch off manually.
Good morning, ladies and gentlemen. We are very pleased to welcome all our distinguished guests to the first International Conference on Mechanical, Industrial, and Electrical Engineering, or ICMIEE 2021,
in conjunction with 14th Seminar Nasional Mesin dan Industri, or SNNE 2021,
and 10th Seminar Nasional Teknologi Komputer dan Telekomunikasi, atau SNTKT 2021,
with the topic Applied Technology for Sustainable Development in Industry 4.0.
We are delighted to welcome our distinguished guests for participating in this conference. To the Honorable Professor Dr. Insinyur Agustinus Purna Irawan as the Rector of Universitas Tarumanagara,
To the distinguished Insinyur Muhammad Sobron Yamin Lubis, MSc PhD, as the Chairman Organizer of ICMIEE 2021,
the respectable Mr. Harto Tanujaya, ST, MT, PhD, as the Dean of Faculty of Engineering of Universitas Tarumanagara,
to the distinguished keynote speakers, Professor Insinyur Dr. Muhammad Zulkifli Abdullah from University Science Malaysia, Malaysia,
Professor Cheng Renchen, PhD from Kunshan University, Taiwan,
and Profesor Dr. Insinyur Mauridi Heri Purnomo, MN, from Institut Teknologi 10 November, Indonesia.
And also we would like to welcome all the presenters and participants of ICMIEE 2021.
For a brief moment, we would like to invite you to rise and sing Indonesian National Anthem and Universitas Tarumanagara Hymn. For the organizer, you can start to play the video, please.
Indonesia, tanah airku, tanah tumpah darahku, di sanalah aku berdiri, jadi pandu hidupku. Indonesia, bangsaku,
has been a great honor for us to have an official opening speech represented by Insinyur Muhammad Sobron Yamin Lubis, MSc, PhD, as the chairman of organizer to deliver the opening speech and announce the official opening of this international conference. To Dr. Sobran, the stage is yours.
Thank you. Assalamualaikum warahmatullahi wabarakatuh. Good morning. The respectable the Tarumanagara Foundation and to the Honorable Professor Engineer Agustinus Purnairawan, Rector of Universitas Tarumanagara, the keynote speaker Professor Engineer Zulkifli Abdullah from University Science Malaysia, Professor Chang Renchen PhD from Punsan University, Professor Dr. Engineer Moridi Heri Purnomo from Institut Teknologi 10 November Indonesia, and I respect for Harto Tanujai PhD as Dean of Faculty Engineering, Universitas Tarumanegara, Lecturer of Engineering Faculty of Invitation, guys, organizing committee, and all students. Ladies and gentlemen, first, let's pray and say thanks to God for giving us His mercy and blessing. The development of technology in the time is growing up so fast, it aims to meet the necessary of the community to get better life. Technological innovation which needed to develop technology product that can help people in improving their life. Therefore, the academics are not only required to implement the learning process, but also must do research and community service to produce innovative scientific research. Research activity today receive a positive reception from academic. Certainly, we need a scientific forum for mutual discussion, exchange information about the research that has been carried out, which will come primarily relate to applied technology for sustainable development in Industry 4.0. Department of Industrial Technology, Faculty of Engineering, Universitas Tarumanegara, with three study program is mechanical engineering, electrical engineering, and industrial engineering. Always develop and carries out the three dharma of higher education activity as a proof of responsibility as a part of higher education institution, especially in the second dharma, namely research and scientific publication. The Department of Industrial Technology has held periodic national seminar every year, so SNMI, SNTKT activities, and the lecture have attended various national and international seminars as speaker. Along with the current development and demand for change in 2021, the Department of Industrial Technology view is very important to improve the quality of the seminar implementation into a joint seminar, the national and international seminar, namely International Conference of Mechanical, Industrial, and Electrical Engineering, or ICMIEE 2021. Ladies and gentlemen, the more extensive the information is obtained, it will be so much knowledge that we gain. Some people are sent by researcher, academic from various countries such as United Kingdom, Australia, China, Singapore, Malaysia, Taiwan, Saudi Arabia, Thailand, will enrich the science in technological development. Paper are categories based on engineering discipline set by the organizing committee. In this conference paper consists of mechanical engineering, industrial engineering, and electrical engineering. Then the presentation is divided into parallel sessions. Ladies and gentlemen, on this occasion, I would like to thank to the Tarumanegara Foundation, Rector of Universitas Tarumanegara, Dean of Faculty Engineering, Universitas Tarumanegara, Lecturer of Faculty Engineering, Universitas Tarumanagara, staff employee of the Faculty of Engineering, Universitas Tarumanagara, Organizing Committee and Scientific Committee of ICMIEE 2021 and sponsorship for the support and help that has been given. I also would like to thank the other we contribute for the cooperation in preparing scientific paper. Finally, I would like to apologize if there were the efficiency in the activity. Thank you. Untar for Indonesia. Good morning. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Dr. Sobron, for the official opening speech. We are delighted to have a welcoming speech represented by Mr. Harto Tanujaya, ST, MT, PhD, as the Dean of Faculty of Engineering of Universitas Tarumanagara, to deliver the welcoming speech. To Dr. Harto, the stage is yours.
Okay, thank you. Good morning. My God bless our intention. Dear Rector of Universitas Tarumanagara, Vice Rector and Director, dear keynote speakers, Professor Dr. Insinyur Mawaridi Heri Purnomo M.Eng from Institute Teknologi 10 November. Welcome in Untar virtually. Nice to meet you, Prof. Professor Chang Renchen, PhD from Kunshan University, Taiwan. Welcome in Untar virtually. Nice to meet you, Prof. Professor Insinyur Dr. Muhammad Zulkifli Abdullah from University Sains, Malaysia. Welcome in Untar virtually. Nice to meet you, Prof. Dear Head of Department, Study Program, lecturers, authors, researchers, undergraduate and graduate students, and ladies and gentlemen, I would like to welcome all of the participants of this webinar. It's my great pleasure to join with you all for the opening of this webinar in International Conference on Mechanical, Industrial, and Electrical Engineering, ICMIEE 2021, and SNME 14, and also SNTKT 10. But the important things, even though the pandemic is still happening in the world, but we can still communicate each other. My God always protect all of us. International Conference on Mechanical, Industrial, and Electrical Engineering was initiated by the Department of Industrial Technology, Faculty of Engineering, Universitas Tarumanagara, which are blended with both National Conference of Seminar Nasional Mesin dan Industri ke-14 and Seminar Nasional Teknologi Komputer dan Telekomunikasi yang ke-10. And the theme of the conference are Applied Technology for Sustainable Development in Industry 4.0. At present, Industry 4.0 is popular topic of interest among students, researchers, professionals, and industry. We hope the theme can be used to motivate and increase our insight, to make we more creative and innovative, and also take advantage of the opportunities in industry in 4.0 era. This webinar particularly encourages the interaction of researchers, academics, and professionals to discuss new and current works in the research. And we know all of the best results if we make collaboration and cooperation with the others. I do hope this webinar to be a valuable forum for all and to share their good research experience, and also this webinar will improve awareness and understanding of the better of life. Finally, I would like to thank so much Professor Dr. Insinyur Mawaridi Heri Purnomo, M.Eng, and Professor Chang Renchen, PhD, and Professor Insinyur Dr. Muhammad Zulkifli Abdullah as our speakers in this morning for sharing with us about your research and your experiences. I also would like to thank all the participants, authors, lecturers, students for the participation in this webinar. And I also say many thanks to all the organizing committee for their hard work and patience in making this webinar success. Please enjoy the webinar. I hope all participants will find the professionally fulfilling, and may God bless all of us. Thank you.
We are grateful to have a welcoming speech by Dr. Harto. Thank you. We are pleased to have an honorable speech represented by Professor Dr. Insinyur Agustinus Purna Irawan, STNT, as the Rector of Universitas Tarumanagara to deliver the speech. To Professor Dr. Agustinus Purna Irawan, the stage is yours.
Thank you, Olivia. Good morning, ladies and gentlemen. Thank you for inviting me to this online international conference, ICMIEE 2021. First of all, I would like to give my thanks to all keynote speakers, Prof. Zul from University Sains Malaysia. Apa kabar, Prof. Zul? Sehat? Semoga sehat ya.
Sehat-sehat. Sehat, Wak. Oke, apa kabar?
Terima kasih sudah datang lagi ke
Alhamdulillah. Oke. Terima kasih kerana menjemput.
Ya, terima kasih Prof. Zul.
Ya.
Prof. Chen, PhD from Kunshan University, Taiwan. Why you, Prof? Taiwan is okay? Okay. Profesor Dr. Insinyur Mauridi Heri, MN, dari Institut Teknologi 10 November, Surabaya, Indonesia. To the moderator, to all speakers, to committee members, and to all participants. The topic is very interesting and very relevant to be discussed at our current condition. We are undergoing to third situation, but let's not forget that there still are opportunities for improvement and development in the future. With all the speakers, we will be able to learn useful knowledge that can be implemented in our research and innovation. I hope the discussion in this conference will give rise to breakthrough that contribute to good research and innovation for everyone. Thank you for collaboration of universities from many countries and universities. I hope this collaboration will continue in the future. To all of my fellow students, lecturers, and participants, I hope you enjoy today's discussion, and don't forget to give your opinion or question at the end of the conference. Finally, dengan mengucap syukur kepada Tuhan Yang Maha Esa, I declare that ICMIEE 2021 officially open. Thank you very much for your attention and contribution. Have a nice online conference. Thank you.
It has been a great honor for us to have your amazing speech today, Professor Dr. Agustinus. Before entering the main session of this conference, we would like to invite all of the presenters and participants to have a photo session. If you don't mind, please be kind to turn on your camera. We will give you a sign for each screen's photo session. For the organizer, you may start to take the picture, please.
Okay, participants, we'll start on the first page. 1, 2, 3. For the second page, 1, 2, 3. The third page, 1, 2, 3. Okay, MC please.
The next session will be the main course of the international conference. We would like to introduce our prestigious keynote speakers. Our first Excellency speaker, Professor Insinyur Dr. Muhammad Zulkifli Abdullah from School of Mechanical Engineering, University Sains Malaysia, Penang, Malaysia, with the topic Porous Media Microcombustion, Analysis of Exergy and Entropy Generation.
Our second Excellency speaker, Professor Chang Ren Chen, PhD, Professor and Chairman of Department of Mechanical Engineering, Kunshan University, Taiwan, Republic of China, with the topic A Business Model of Sustainable Agriculture that Combines Green Energy and Water Resources, Taiwan Practice.
And our third Excellency speaker, Professor Dr. Insinyur Mauridi Heri Purnomo, M.Eng, from Department of Electrical Engineering, Institut Teknologi 10 November, Surabaya, Indonesia, with the topic Utilizing IoT to Design Innovation Based on Human Behavior in the Education Sector within COVID-19 Pandemic.
The session will be moderated by Dr. Insinyur Erwin Shahaan, MSE. Dr. Erwin Shahaan is an associate professor in Mechanical Engineering Study Program of the School of Engineering Universitas Tarumanagara, Jakarta, Indonesia. He has an expertise on metallurgy and corrosion, with practical research has focused on lead-free solder, on revealing corrosion mechanisms and designing corrosion-resistant alloys and coatings. He has been giving lectures on the selection material processes, failure analysis, structural dynamics, system dynamics, and corrosion and its application. He graduated his bachelor, master, and doctorate degree at Universitas Indonesia. He had been also as a research assistant at Synergy Industrial Research Group at Mechanical Engineering Department, Sheffield Hallam University in the United Kingdom since 1998 until 2003. He has a publication about the effect of zinc composition in melting point and microstructure of lead-free solder, an international journal of engineering and science. And also, he has a publication about the usage of nickel pig iron for low alloy steel purpose, an international journal of innovative science, engineering, and technology. Dr. Erwin has a membership as a professional member of Surface Mounts and Technology Associations, Chapter Penang, Malaysia, and a professional member of National American Corrosion Engineer.
As a reminder, we will introduce how to ask the question during the keynote session using the Slido application. For the organizer, you can start the video, please.
Okay, so Slido application can be visited using any device from the search engines by typing slido.com.
Then, please enter the code number 24244 in the column shown in the website or simply scan the QR code shown in the video.
You will be delivered to the ICMIEE Q&A room, and you may type a question you want to ask the keynote speaker.
Every question that are delivered will be shown on the room so you can see other people's questions from your device.
You may also give a thumbs up if you like one of the questions.
The question with the most likes will be shown at the top of the page.
At the Q&A session, the moderator will read the question starting from the top of the page.
So, please make sure to like the question that you would like to ask the keynote speaker.
Okay, now, shall we continue to the keynote session, Dr. Erwin?
Please.
Okay, so Dr. Erwin Shahaan, the stage is yours.
Thank you to host Alivia and Hideki. Okay, first of all, good morning, I would like to welcome all the distinguished participants, Rektor Universitas of Tarumanegara, Profesor Dr. Insinyur Agustinus Purna Irawan, Dean of School Faculty of Engineering, Universitas of Tarumanegara, Arto Tanujaya, SDMT PhD, and Head of Committee of ICMIEE, Insinyur Sobron Lubis, MSc PhD. And also, we would like to welcome all our honors keynote speakers who will deliver the articles to inspiring us in this morning. The first speaker is Professor Dr. Insinyur M. Zulkifli Abdullah. Good morning, Prof. I think we have seen for ages, Prof. And
yeah, morning, Prof.
We met.
I hope you are fine and well.
Okay,
in Jakarta.
Alhamdulillah, Prof.
Alhamdulillah,
we
good.
met through by the cable, Prof. Yeah, okay.
Yeah.
And the second speaker is Professor Cheng Cheng Chandran. I think I've done a PhD. I mean, I would like to forgive me if I've mistaken to call your name. And the third one is Professor Dr. Insinyur Mauridi Heri Purnomo, Master of Engineering. So we have now three keynote speakers. The honors keynote speakers will be delivered all of the knowledge, and we hope that they could be inspiring us all the knowledge and increase our knowledge. Okay. Now I would like, please allow me, I would like to brief shortly about the CV of Professor Dr. Insinyur Zulkifli at the moment. Right. I think if we look at the CV of Professor Zulkifli, it's quite long, and I just take it out of with the shortly brief that could be. He has a degree from the Bachelor of Engineering from Swansea, UK, and Master degree and Doctor degree from Strathclyde, UK. And also, he had been as a dean of deputy dean in School of Engineering, and here a lot of publication has been published from Professor Jul, and it could be effective to the inspiring this morning. And now I would like to be pleased Professor Jul to deliver the talk this morning. Thank you. Hello. So, have you heard my voice, please? Yes, Professor Jul.
Yes. Okay. Can you hear me?
Yes.
Can?
I can hear you.
Okay. Assalamualaikum. Salam sejahtera and good morning, everyone. I'm very sorry for the glitch on the mute. All right. First of all, I would like to thank you, the organizing committee, for inviting me this morning for the keynote speaker in the ICMIEE conference 2021. I always happy to be with you in UNTA, especially with my my friends, director, Professor Agus Anustinus, for always be kind to me, and then Professor Dr. Erwin also, and then Dr. Honto, and then Dr. Sobron. Thank you for inviting me this morning to give a keynote speaker. Today I would like to talk. Let me share the screen with you. I will share the screen now. Sorry. Share. Sorry, I'm not really familiar with WeShare. That's why normally we use Webex in our school. That's why it's a bit difficult to use. Okay. All right. This morning I want to talk about bit different. Normally I talk more on the solder and then SMT process. Now today I just want to talk on the porous media macro combustion. I'm going to focus analysis of exergy. This exergy means the available energy during the combustion. And then also we're going to touch also entropy generation involved during the combustion in the micro porous media micro combustion. All right. Actually, this project have been working almost 12 years now, and then we have a few PhD students already graduate from this particular subject, and today actually I come from University Science Malaysia, and then I'm in the School of Mechanical Engineering as a professor there, right? Okay, let me introduce a little bit about my lab. All right, this is what we call it lab, and then I have one research officer. If you can see here, this is my right hand man to help in the research. I have a MSc student, 5, right? One of them is here. Okay, is from Bangladesh, and then we have a PhD is 8. These are all PhD student. But today I want to talk about micro combustion, and then it's work by this Nazmi. I think he been to UNTA last time in the TK conference. I think Prof. Agus still remember him, I think, right? Total my student is about 14 students altogether, all right, right now. Okay, let me begin our thoughts with this outline. I will going to touch the slide, my presentation by introduction to combustion and also porous media. What is a porous media? And then I'm going to touch about problem statement. I'm also going to talk about what is our objective for this particular project, and then literature review, material and methods. I'm also going to touch on the result and discussion, and then finally I will touch on the conclusion, and then I glance through some publication and reference that I already used. Right? Okay, let me start. I think most of you aware about combustion. I think mechanical is not is so important for mechanical graduates, mechanical engineer, and so on. As we know, although it's a multi-discipline in nature because it involves chemicals, there, and then involve emission. All right. Actually, it's a strict concept. They have a few need to have oxygen or oxider, we call it, and then we need some initial from fuel, and the chemical reaction taking place. When chemical taking place, then it generate heat, right? Then heat some also can have emission from there. And then if we look at in the definition of by Oxford Dictionary, it said that the process of burning or a chemical process in a substance with a substance combined with the oxygen in the air to produce heat and light. All right, this is the definition given by Oxford. All right. Basically, I think you aware, right? Maybe younger generation might be, it's very hard to see this kind of light, right? During my school children, my childhood, I always use this light, right? In Malaysia, in my grandmother and grandfather don't have electricity at that time. We only use this lamp, what we call it kerosene lamp. This kerosene lamp have a wick inside. This wick actually is a porous media because there's a capillarization. They have a kerosene inside. Then the kerosene we flow through the wicks, and then if we ignite, and then they have a light burning, and then we're going to have a clear or bright light, right, come out from the this kerosene lamp, right? And then of course kerosene lamp is a liquid fuel, and then the emission is big high, and then during that time we didn't really bother, right? But now if we use kerosene lamp, and then we feel we cannot stand, right? Now new generation student cannot stand with the smell of the kerosene. All right. We also have also like a cooker, also have a kerosene use, and then if you see there's unburned carbon there on the kettle, right? This how difficult to handle with this kerosene stove, right? It's a very high emission, right? But now we when we come modern, become a developing country or developed country, now you are facing a new device, new cooker. Now we have the cooker, very nice, nice combustion, and then we less emission, all right? Okay, like this LPG cooker, but still have a kerosene. In the developed country like Japan, they still use because it's cheaper, and then it's safe to be used. And then this kerosene you don't feel a smell or emission because they have a proper catalyst to remove that emission, right? That is how the system become better and better for nowadays, right? Okay, what is a porous media? Porous media is the material that we have a pore, because they have two types. They have a discrete type, and then they have foam type, right? Discrete type also some people use, right? They have a ball. We can arrange the ball on the stove, and then we flow through a gas through the porous ball. From the ball, they have a porous in between. They have a gap in between the ball, and then we can start to initiate, and then combustion taking place inside the porous and also outside the porous. And then the most better one, we use a foam type, right? Foam type, we have can control the pore size. If we want to have a bigger pore size, we can buy or make a bigger pore size. If we want to have a smaller pore size, and then we can can have that. We can order that, right? They have already available on the market on this particular form porous media, right? And then they have a different type of material, right? This alumina foam, right? In USM we are developed this one. We manufacture this porcelain foam, right? Because it's easier to handle. But we cannot do this. But this one is a silicon carbide porous media. It's quite tough. That is very good. And then they have a very strong and then very high conductivity also. And then of course it's more expensive. But to manufacture this one is quite difficult. Right? We don't have facility yet to do that. All right. So same thing. If you use alumina ball, we have a small. Bigger size, you can select from there any size you like to control the pore. You can also combine bigger and smaller also in order to get a correct combination of the pore size for for your combustion, right? And then what we are doing now is normally is use a form. What in this particular project we try earlier with a smaller pore and a bigger pore. And then for combustion in the porous media, we're going to have two layers. That what we call the preheat layer. Preheat layer normally a smaller pore, okay? And then we have a reaction layer. Reaction layer is bigger pore, right? Because these are smaller pore, we protect us from flashback, right? And then a safety issue will be a problem. Therefore, if we put it smaller pore, and then we safeguard to have a flashback issue, right? Okay, these are porous media combustion. Porous media combustion are taking place whether inside the porous media or on the surface of porous media, right? We can control. If like, for example, our cooker without porous media, we cannot have what we call the flameless, right? In normal cooker without porous media, we cannot have a flameless combustion. But for porous media, we can have both, whether it's flameless or surface flame, right? When what we call the combustion within the porous media, or normally people known as a metric stabilized combustion, or some people say submerged combustion, right? It depends on the individual to use the word. All right. Also, we have a combustion at the surface, and that means we can see the flame, and that what we call it surface stabilized combustion. We call it, okay, because the flame are stable on the surface, right? This is the terminology used in the porous media combustion. All right. If you see this, the picture, these are porous media. If you see, this will become very yellow or red color, right? Yellowish, orange color. This is very hot. When it's very hot, these are radiation are very important there, right? Because when a temperature go 500, 600, therefore radiation are very, very high, right? Unless if you have a convection, I mean, without porous media, they have a flame on the surface. You see that the porous media on the surface, porous media is not hot. Therefore, the flame more on the convection, heat transfer, right? If the porous media become hot and then less flame, that mean the radiation are very important, and then the heat transfer mainly through radiation, right? That's why when we normally, if we want to cook, we want to have a flame normally, or if you want to have a satay, then we don't want to have a flame, right? We want to have more radiation in the to make a better, nice, tasty type of food, right? That's how you can select if you use a porous media combustion, right? All right, this is the idea of porous media. We have a higher for preheat layer, and then preheat layer here. This is a reaction layer, and then the heat, fuel coming from the bottom pass through the preheat layer, and then there is a interface between high pore and low pore material, and then if we have a combustion in the submerged combustion, and then we have a flame develop in between this. That means the reaction layer will become very hot. That means here will be more radiation taking place, right? If we want to have a surface combustion, I mean we push the flame, and then he stabilize the combustion at the surface. When it's stabilized here, the flame we can see. If stabilized here, the flame we cannot see, right? Only this one become hot, right? That is what we call it flameless combustion, right? All right, this is advantage of porous media combustion. It is normally increase combustion efficiency. The most important, reduce pollution, especially NOx, CO, and urban hydrocarbon. And then we have high power density and modularization, better heat transfer via conduction, convection, and radiation. That means we can we can choose whether we want to have surface flame, that means convection will be better. If we have flameless, that means conduction and radiation become better, right? Suitable for burning ultra lean fuel. That's why we also can have a low fuel rate, right? And then also high fuel rate. That means we can control those. If the without porous media, you cannot control. You can normally high flame rate, normally more than 1 stoichiometry or equivalent ratio, right? Okay, best suited for low, and then it's good for low calorific value fuel, right? Okay. All right, these are normally stringent by the European Committee. They are really encourage, really control the emission. Normally, if you see in the German, we only allow to have 200 ppm of the NOx, and then also 100 ppm of CO, right? These are normally guideline for them. That means normally the allowable in the Swiss more stringent, and then if we can see that from porous media, normally emission is lower, right? Emission is lower, especially when we're dealing with low equivalent ratio. That means we have stabilized flameless combustion, right? Okay, these are application. The application of porous media combustion is many. We have a radiant burner, household, many things. Caravan heating, steam generator, all air heating system, IC engine, gas turbine, oil, hydrogen production, etc. Okay, that's all. But we are normally focused more in our research on the household burner. That means a cooker, right? We try to have a small cooker with porous media, and then we can have a flame combustion and flameless combustion, right? This is what our statement. Most of domestic or conventional burner operate by open flame combustion. The type of combustion reduce the combustion and thermal efficiency of the burner due to inappropriate mixing of air fuel. Air fuel is very important. This may also lead to the high fuel consumption, high CO, and with unburned hydrocarbon, right? That is what we want to use of porous media combustion. The mode of the heat transfer of firm flame combustion normally by conduction and convection, but with PMC offer better energy conversion by including heat transfer through radiation. That's what. And then we also can reduce, especially NOx, in a very low, right? And combustion with poor fuel mixture can reduce performance of burner. The burner with porous media is better option to produce high flame temperature with better emission. That's what we try to use porous media in order to remove the problem or to reduce the problem. All right, the objective of this particular topic or data or the student right now is to test the performance of porous media burner experimentally by using butane fuel. We use a butane and then various fuel mixture. We start from lean, below 1 per equivalent ratio, and then we go higher than 1 at a rich mixture. Then to observe the flame stability, right, of porous media burner at various equivalent ratio, to analyze the entropy generation, energy loss, and energy efficiency of porous media combustion, right? Porous media performance. All right, there's a few works already published. This topic is not new; it's quite old already. And then, but still, people are doing on this particular field because they know the advantage of porous media, right? They have most of them are doing experimental work, but if you see numerical also there, but still people are doing most like 2D simulation. We cannot see a 3D simulation yet for the porous media combustion. That's why it is good also to study 3D. They have one 3D here are doing that, but most of them are doing 2D, all right? Simulation. All right, this is also the article that relate to the entropy generation, because entropy are also very important during the combustion, because entropy change not only chemical reaction, but also through losses through fluid flow, or mixture flow, or heat through the biggest one from heat transfer. Yeah? The entropy generation from the transfer. Right, these are a few people are working on that to study what is the entropy for the various fuel. All right, so far butane is not yet. We are doing on butane now. Okay, the method we only use experimental experimental study now. Study on the flame temperature, emission on different type of porous media by using different layer and equivalent ratio, right? Introduce different material. We also use porcelain and alumina as a preheat and reaction. Porcelain we use a preheat, and alumina we use a reaction, because alumina is more stronger, porcelain is weaker, right? And then we also measure the maximum temperature available during the combustion, and then to observe emission level, CO and NO, for different layer of arrangement, right? This is the experimental setup. This is a butane, right? And then we supply with some air pump to give sufficient air, right? Because we have a premix mixture in the burner. These are butane there, and the air coming, and then mixture, and then go to this porous media, and then this is the flame, right? And then we measure through a thermocouple on the wall, and then across the wall, and also on the plane itself. And then we see the flame something like this, right? We have a small diameter of the burner, and then based on that we observe the flame, and then we control whether it's surface combustion or submerged combustion, right? And then all the data we store in the computer through DAQ, what we have to measure the temperature. And then we measure the flow rate through the this device, right? This flow rate air and fuel flow meter. Right. These are what we can see if we can mix the fuel coming from this, and then free mix here, and then again when it come to the preheat layer, they have a mixture more here, and then pass through the reaction layer. These are reaction layer, and then if we start combustion here, that means we have a flame combustion, and then we have a flame at the top, and then we measure the temperature of the flame, because we want to find where is the maximum location of the flame, the temperature, and then we have a different level of thermocouple there, right? We also measure across this to measure across the reaction layer, and also preheat layer, so to see whether heat loss through this part we can counter, right? We can measure, right?
Hello, Prof.
All right, these are the form we use. For preheat layer, we use a porcelain 26 ppm per centimeter, and then we have a alumina form 8 ppm is more bigger, right? And then this alumina we buy from this good fellow, and this porcelain we make ourselves through School of Material and Mineral Process, Mineral Resources Engineering in our campus. Yes.
Hello.
Yeah.
Prof. Jul, 2 minutes left, please, Pak.
Oh, I have many things. Okay, let me go straight to the result. Okay.
Okay. Thanks, Prof. Okay.
Oh, sorry. Oh, I thought I'm okay. Sorry. All right. When it's come to combustion, we have a flame, right? These are what we call it without porous media. If you see, without porous media, you cannot have you must have higher equivalent ratio. We start with 1.3 equivalent ratio up to 2, and then we see the flame. If you can see the flame, the combustion are nicely well developed, and then we can see, if you see a yellowish, that means incomplete combustion start. include combustion for the fuel start. This is how we see the from the without porous media. Then with porous media, if we can see, these are porous media at 1.3, similar to what we did in without porous media. And then we have a very bluish color. It's very nice combustion, but it start to become a yellow, and yellow to that. This is incomplete combustion start. It start very late at 1.6 up to 2 equivalent ratio. And if you see, if you want to use as a cooking, that means the blue is better. But if you want to use as a light, the higher equivalent ratio is better, because give a brighter in the room, in the house. Okay, this is how submerged combustion. If come to submerged, and then there is hot, all right, hot, and then we cannot see the flame, right? That means it's become hot inside, and then the radiation taking place, right? These are normally at low equivalent ratio start 0.6 to 1.2, but 1.2 already have, we can see the flame there. If possible less than 1, we cannot see the flame. This is how we control the combustion. All right, the maximum temperature vary depend on the equivalent ratio. The highest are during the rich condition, and then, but interestingly, at the stoichiometry, when equivalent ratio equal to 1, the variation of temperature is not much there compared to other combination, right? Okay, this temperature variation across the wall, that means the heat loss through the wall, and then we see that for bottom porcelain is the lowest, and then in the reaction layer is more higher there, right? Okay, these are what we call it NO and CO. This when we do porous media, definitely not NO and NO are lower, less than 25, right? But when it comes to CO is higher when it become a surface flame. Okay, in the rich condition, in the rich mixture, the highest on the CO side, right? Whereby is in the flameless, right? When low equivalent ratio is become the CO is very low, almost zero there, right? Okay, this is the total entropy generation is higher highest at the for the rich, right? But it's a very low at the stoichiometry, right? Similarly, energy also, we see that stoichiometry are the lowest energy loss, right? These are lost through the wall for the flameless, and then this the energy destroy. Okay, energy destroy. They have a lowest at the stoichiometry, but lower also in the low equivalent ratio, but higher on the higher rich condition, right? And then finally this efficiency. If we see that, of course, efficiency is higher with the higher fuel rate, rich condition, and then we see that lower at that particular 0.8 there, but gradually increase, right? When it comes a higher equivalent ratio, right? And then this I'm sorry, this is my final concluding. The effect of equivalent ratio is an important parameter on the temperature distribution, entropy generation, energy efficiency on the surface flame combustion in the upper system. Thermocouple temperature confirm that the flame stability in 23 millimeter diameter double layer at 1 due to a stable flame, right? The highest exergy efficiency at 50% at equivalent ratio of 1.2, and the lowest exergy is 47.4 at 0.8 for the lean, right? The entropy generation is reduced for the lean mixture, and then increase significantly for rich mixture. That's why is lean mixture low entropy there. Okay, at equivalent ratio 1.0 produce optimal performance with lower entropy generation and energy loss. the efficiency of exegy of the research show that link is reduced, and then for reach increase in between 0.9 to 1.2, not really reach 0.9 to 1.2 increase, and submerge due to submerge and surface flame respectively developed inside porous media. Right. With that, there's a few publication of my works during these 11 years of work, and then we also have a reference there for this particular presentation. I think that's all. I'm very sorry because take more time. I hope you manage to understand what I'm trying to say, because I go very fast at the end of the speech. All right, that's all. Thank you.
Okay, Professor Joel, thanks very much for your very interesting presentation this morning, and we hope it could be inspire us to have more knowledge about the combustion system. So I don't know, probably could we could give applause to Professor Joel, because probably every single participant appreciate to respect to Professor Joel presentation. And the second present the keynote speakers, I would like to be pleased to Professor Dr. Professor Chen Changreng PhD. Professor Chen Changreng PhD. Oh, before Professor Chen Changreng PhD started, I would like to give a mention about the our session this morning, because actually keynote session, it consists to the two sessions actually. There could be the one session is a presentation for the from the keynote speakers, and the second is the Q&A session. So now all the participants, if you have already a question, probably will be delivered and addressed to the keynote speakers after all the keynote speakers presented the article. Okay, I would like to be pleased Professor Chen Changren, PhD. Hello, Professor Chen. Hello. Could you hear my voice, please, Professor Chen? All right, so already here now. Professor Chen, good morning. Professor Chen. I think we still haven't get hear your voice, please, Professor Chen. Okay, good. Okay, before you started, I would like to short briefly your CV. Allow me to brief shortly Professor Chen's CV. The name Professor Chen Changren, an education PhD from Missouri State University, and Master of Institute of Mechanical Engineering National Taiwan, Bachelor of Department of Machinery, Tsinghua University. And in this CV of Professor Cheng is quite a lot about the publication and also book published here. And now he is as the as a lecturer in Kunshan University. So now, Professor Chen, the state of for you, President. Hello, Professor Chen. Professor Chen? Hello? Hello, Professor Chen? Hello, Professor Chang Ren Chen? Hello? Okay. Professor Chen already delivered the video, but Professor is still available and standby in this moment, in this morning. Could the committee please share the video of Professor Chen? Thank you.
Hi, good morning, Professor Moridi. Hi, good morning, Professor Moridi Henry and Professor Mo Rukifly Abdallah. I'm very great to attend this ICMIEE. My name is Chan Ren Chen. I represent from Punshan University in Taiwan and also the Taiwan Agriculture Optoelectric Association. I'm working for green energy and the water resource for many years. I find out so we have to introduce circular economic and the green community. So in order to make the whole sustainable, so I would like to have the opportunity to share some point of view. Today my topic will be business model of sustainable agriculture that combine green energy and the water resource. Okay, and let's begin. Okay. Today's speech outline will be sustainable agriculture and the SDG. And we have the second topic will be crisis of the present agriculture industry. And we will combine with the chance, combine with the I4 in agriculture 4.0. So I will introduce my point of view about business model with I4. And of course, circularity is very important to make it work. And finally, we have to make the conclusion remark. So the second part, I would introduce our Taiwanese practice. So it would be regarding in following. Okay, sustainable SDG, to make the sustainable agriculture work. So you combine not only agriculture, you also need to include many others. So I would no poverty, no hunger, clean water, clean energy, decent work, industry, innovation of the infrastructure, and so on. So where there is the topic involved in those called the sustainable topic. So in the World Wildlife Fund, they have announced. So the days we are facing the pollution, okay, agricultural pollution, and the agriculture and the poverty, okay, and water consumption and climate change. So that's why the agriculture is poison fresh water, the waste, okay, agricultural waste, they pollute a lot. So especially the poison of fresh water, marine ecosystem, and air and soil. And another time, and for the sustainable agricultural farming. So because the subsidy provided from US and the European government, so make the encourage overproduction. So it provide very cheap to all the world. So it will influence the overall the agriculture industry, and also the water programs. And the last one is climate change, what goes about the disaster. Okay, so we have to care about the fossil. We have to use green energies. So Taiwan also, Taiwan agriculture also facing the same problems. So this result, this is not with full of water. So it is very very good the fuel. However, if you should if the rural place there's a shortage of water and energy, so it would because there's the profit, the agricultural products is very cheap, so it cannot make money enough profit to sustain. So finally, a lot of the place getting short, with shortage of water and energy. So it would becomes waste. Nobody to. So all of this kind of the Taiwanese field becomes less and less. So that's why we are facing the problem. So, and another thing, the rivers is serious polluted because the waste of the living the waste from the polluted waste the river. So our EPA make announcement they 81% domestic storage, and 10% come from livestock wastewater. Okay, and the 8.7% come from industry wastewater. So we have measured the 9 series polluted. So it's come from the domestic storage 6 stations, and the 3 stations it is livestock wastewater. So you can see the polluted come from the rivers is very serious. So we have to try to the use water treatment. So we have to install, connect to collect the sewage, the water to have the water treatment before you leak it out to the river. And also we have to make use of the living stocks wastewater to transfer to other to the biogas and the fertilizer. So it can be this kind of what I mean the circular economic. So we should reduce the waste from the agriculture and the livelihood. And a lot of the papers talk about sustainable agriculture. So because we have to face the problem in 2050, then we need approximate more 70 more foods. So right now we are facing the land decline. So how can we increase 70% more? So we need to use other way for our agriculture. Okay, so we have no chance to move to the sustainable agriculture. Okay, so the sustainable agriculture should meet the society needs for good quality and agro products without impacting the future generation, because we want to care about the environments. We want to create a good product, not to lose the next the environment attack. So we have to find equipment for the product of food and preserve ecosystem. And the third is we have to help the farmer to achieve economic stability, to improve their quality of life. This kind of thing, it is very important for sustainable agriculture. So in order to fulfill those three, so we have to this is a must. We have to go to the future. So I think profitable and partnership and community of cooperation, it is very key to make successful. So people get involved in not only the grower and consumer and retailers and research. Everybody should serve the same opinion for this. So grower, they have to, for the training, they have to share how to the tool to use for healthy, the soil healthy, and minimum the water usage and lower pollutant level. And consumer should not only they have to encourage that, and we are working on the value added food. So we need to have the farmer promote the farm worker well-being and environment friendly, and strengthen the local economic. So consumer also have that kind of commitment to choose the right product, to promote the farm worker well-being. And researchers is very important to have to work out combining biologic, economic, engineering, all kinds of works, innovation, so to help to everybody work together. So those people should get involved, and there's no negotiation. We are not trying to find the overproduction. However, we need to fulfill the customer needs, and also we protect the environment. So this is the kind of the negotiation, and then work together in the community. So to make that make the profitable to the older people get involved. And in the EU sustainable agriculture in EU, they care about the social sustainability. It is also very important. So you have to community get involved, and also we need to have the economic sustainability and environmental sustainability. So those three key pillars. And I would like to mention it is very important to have the modernized agriculture. So we should have the new technology, research, innovation, So this kind should be to make the transition from traditional agriculture to the modern agriculture and to reach the sustainable agriculture. So this is really important. So nowadays we have the I4. They connect. We have a lot of big data, so we can help the farmer to have all kinds of the precision manufacture to help them to reduce the loss, also low impact to the environment. So this also get involved another topic, water and energy. This topic we should get involved. So before time, it is not possible. Everybody work individual. Since we have the I4 technology, they can have the very smart way to provide the decision and help each other to have the link together. The more link, the more strong the whole agriculture, the system to be sustainable. So this is ongoing. There's a lot of opportunity. So I can think about the sustainable food production system. We should take measures to ensure commercial market for food and develop the product function normally and obtain market information as scheduled. And timing, seasonally control, including growth, storage, and reduce extreme price fluctuation. So this is a kind of the customer needs and the production. So it is become we should make the knowledge to make it happen, to balance. Okay, so there will be no to reduce the fluctuation. Okay, sustainable. I would say sustainable agriculture is a kind of the production, sustainable production way, and we should also include green energy. Okay, green energy make it low impact to the environment, and water management. Water is very important for the agriculture to sustainable, and the most important is the supply chain. The supply chain, we should make it low carbon, and then therefore they can have a strong competitive, competent, okay, and distribution, eco system, and all to link together. We need to use the I4 technology. So the business model should involve green economic. So and circularity to strive the supply chain sustainable. So these are concepts to use new technology, but you should get involved to the social responsibility to the whole community. And circularity is the drive. You can make the supply chain more competitive. So therefore, you can become more sustainable. Say something for this. And last year, we have been Japan to visit the optoelectric farm. So Japan, it is encouraging the farmer to have the solar energy on the plant, okay, to get the green energy. So you could help them. The machine can be used electric, so there's no pollution for that. Okay, then later on they can be if the grid is shut down, then they can provide energy to the local community. The only thing, if you install the optical electric, so you have to make sure the production, agriculture production over 70%. Okay, this is allowable for the Japanese government, the regulation. So in Taiwan, we will do it the same. Okay, so we will encourage people to the farmer in here. But we don't. The reason we want to use green energy because we don't want to use the fossil fuel. Okay, because fossil fuel is centralized, and this kind of the green energy is decentralized. You can survive anywhere. And so in the future, all over the world, no fossil fuel. Then all the energy will be decentralized. So this is right now we have. Okay, so this is my suggest business model. So I will not focus on the right now whatever sustainable agriculture is doing. So this is a must we should do, and then to I4. So we can do a lot of things. The more linkage, the more powerful to each element for this. I will focus on the water resource and energy. So this is very very good to improve the supply chain. So supply chain is very it should be sustainable. So we need to have very strong linkage to the green energy. But this kind of linkage should need Industry 4, big data, information linked together to make it more powerful. And the bottom is the financial. Financial always important. Whenever we are doing the security, we have a lot of the banner. We start somewhere. So small business company, they cannot do without financial support. Otherwise, it would be fair easily. So this is very important. We want to have the green financial service. So Taiwan, we have we are now push on this. Our government try to do this, and every enterprise they should make a annual report. Okay, CSG report. So they would need to mention how it make this invest on the social responsibility. So if everybody pay attention on this, and to make a stronger the supply chain. And another thing is the consumer. Consumer, we should educate them to become the green consumer. So why this is important? So you will push the whole system. And as long as we provide all the data to the consumer, provide to them how the green the farmer they are doing, and they provide healthy goods. Okay, healthy, and they also care about the environment protection. So the consumer can choose whatever product which is green. Then this is the driving force to make the whole system work. Okay, so the I4 the more stronger we have more benefit on this. But the more important is the driving. Okay, the driving first, and make it balanced. We want the farmer to have the profit. So we have to plan the products, okay, according to the needs. So this kind of we should have the iPhone, okay, to make it work. So this is the time. So we have very good opportunity to make the whole world green and sustainable. So all the things should work together. Okay, should work together. Okay, my point is, my speech is focused on the green and circularity. Okay, and green energy, water, and the circularity. Make it work, and then will provide very good supply chain, sustainable supply chain to the customer. So this is the key point right? So I would make a conclusion here. Strengthening the competitivity of agriculture product, we should have the very good supply chain, sustainable and circularity. So, so we should share a platform. Okay, it's just like Akiba doing an intelligent environment monitor system and modernized low carbon facility and low carbon frozen. So frozen warehouse can make the production and the consuming the meat to be balanced. Okay, you can make it balanced. It's very good, but it is traditionally it consumes a lot of energy. So we should try to reduce the cost by using green energy. Okay, and low carbon transportation is also, and convert waste. This is circular. Okay, to the organic fertilizer. So this is very useful. Also, this will increase the income of the farmer. So to do this, we can have the climate action at the plot. So we can reduce water consumption. So we should try to find out the technology and the tool to have the smart using the water, okay, and waste pollution reduction. So we have to recirculate, try to reduce the waste. Waste resource can become a lot of the resource can be used, water, okay. So this water is very important. So we need to pay a lot of attention on the water resource. And permaculture partnerships, participant. So all kind of government should develop farming area. So this is the you should try to more and more community, encourage community work together, okay, to share the same vision to do that. So to educate them to do the sustainable way to do that agriculture. And human resource, we should encourage people, educate young person to become professional farmer. Okay, because a lot of the young person they leave their country to the city, so we should encourage them to go back, okay, to join the agriculture industry. So that's why we need to provide to cultivate and research personnel on the agriculture. So also the funding, financial funding is also very important, and community style partnership. Okay, so just like seed farm, so all kinds of that should be work together. Okay, and the most important is the driving force. Driving for customers should have the we provide a very convenient information to the customer, and then to also CSR, this the enterprise. Therefore, so so they can consume the seasonally local. This is the low carbon footprint. So they can then help the balance of the production and the consuming. And financial support and tax incentive. This is the government should to do something on the circularity to make the whole waste reduced, but also good for the environment. So this is what I point out what I found and share with you. And next one, I would like to introduce the what we have in Taiwanese. Okay, the waste management. So we try to agricultural waste. We try to make use of it and to transfer to the energy and fertilizer. And this is the our government try to push. And because the river polluted, so we have to correct it and concentrate to make use of the waste and try to convert it to the fertilizer. So if the benefit can save water usage and power saving. You can use the generator power, and cost you can use a fertilizer, and it will cost and fertilizing music. So this is helpful to the environment, and this our government trying to push. Okay, so in this another is eco mass water solution. So you can this kind of the tool, you can dribble the water, and water was surrounding outside, go to the ditch underground. Okay, and the amazing is the soil will not go into this this tube. This is plastic tube. Okay, so this I think this is the you can this anti-crack. Okay, so I will show you the video if we have time. Okay, so this how it will work, especially for that. Yeah, any kind of the product, agricultural product, plants, or any. It depends how did the root. So you can treat the water, and water will go surrounding, go into the deeper. So usually we are irrigating the water on the ground, but sometimes it was stuck on the surface. So the water, as long as it's sealed together and the soil stay together, the water cannot go in. Okay, so this kind of tool will help the water easily go in. Not only water going, air will go in, and you can use fertilizer. Very smartly, you can save the fertilizer. So you can allow benefit for that. This will be also a very good tool. I would like to strongly recommend. So this is the company that I visit, and you can see whatever the experiment. It's only one tube can help the root healthy, and once the root healthy, the product, agriculture product, will get more products outcoming. Okay, also Kunshan University also we are focused on the purification of the used water. So we have to have the clean water for the industry purpose. So this is the way to help the water go to underground, and once this is the pipe we installed and fell into, then without the tube, the water saturates inside, then it will not go anywhere, the product everywhere. Then if we build the pipe, then the water, once the water go go to the tube. The tube can go anywhere freely. Okay. Before that, the water cannot go, so we can let go the water very easily. Then once the water go out, the water will continuously go down. You will not cause flooding problem. So this is the very good tool to do that. And even in the pavement, the pavement untransmitted. So you can install a small tube. Once the water go inside, you get underground, you go anywhere. So you will not, the pavement will not flood it. So it is a very good tool for resistant city to use. Okay, so for the irrigation also, the automatic irrigation for the whole field of grasses. So you can use this just like to underground. Then you could they can evenly distribute the water to everywhere. Okay, once this kind of tool. And another thing is, if you want to control the humidity, so you can make the ground dry. So you can avoid the pests and the grass. Okay, and also the Japanese another. There's a village. They are very special is the house, is the triangle house, and the whole village people they every 30 years they build together this kind of house. So they have very good culture and seasonally a lot of tourists to visit. So you can see sustainable the community should work together, not only for agriculture. So agriculture is part of the community. So so this kind of thing would help the whole world become sustainable. Okay. So the water treatment is surrounding the house. Therefore, you can easily go down to the it's underground. Deep underground. So as long as you have the water go in, then we will go surrounding to the underground. And the whole important is the air will also go in. Okay, therefore you can maintain the roots healthy. Okay, and also the soil will not go in. So this is their invention for that. And also irrigation. I will show you some video for this. And amazing. It's very easy to you just dig the hole and then insert the pipe. That's it. Okay, it's very easy to go underground. Go to the underground. Because the water in the soil underground.
Okay, we can stop
the
video.
The speaker. And you can let the water easily go down. Okay, go down without any okay. And this kind of the tool can also use for resistant city to avoid the flooding. We can storage the water underground. Okay, underground we got plenty of the storage for the water.
Okay.
And another one is the irrigation system and the train system.
Okay, please stop the video. Okay.
Okay.
Thank you. Finally, can you hear me?
Yes, of course, Professor.
Yeah. The whole speech. I'm sorry, my English is not so good. So
it's all right.
I just express my idea.
This is for The video will show you when you drink the water, and the water will go calibrated.
Hello?
Yes.
Yes. I think this is all my speech. I just simply express my thinking how to make agriculture stronger. So as a traditional agriculture way to do that is not the way. We have to think about something bigger, including the customer supply chain and I4 information sharing, all kinds to also get the community get involved. So everyone participant is very important. Okay, this is my idea. I want to share with you how can we make it agriculture sustainable. Okay, thank you.
Okay, Professor Changren, that's all?
Yeah, that's all for my speech.
Okay, thank you very much. Thank you very much, Prof. Changren. It's quite interesting for us and quite give impress to all of us about you talking about the agriculture industrial. I mean agriculture sustainability. I think that's quite important for the, especially for the agricultural country like Indonesia and Taiwan as well. I think. Thank you very much,
Yes.
Prof. Changren.
Okay.
Right?
Yeah, thank you.
Okay, I think okay, could you join with us in the Q and A
Q&A.
session?
When will be the Q&A?
Q&A, yeah? You're still here, yeah? You can join,
No,
right?
I have to go somewhere in the lunchtime.
All right.
Yes.
So you couldn't join us in the Q&A session.
What time is the Q&A section?
I think about 30 minutes or 40 minutes afterward. Is that all right?
Yeah, sure.
Okay, thank you, Mr. Changten. Right?
Yeah, sure.
Thank you very much once more again, and ladies and gentlemen, all participants. Now, the third keynote speakers is Professor Maudi. Hang on. Mauridi Heru Purnomo, Master of Engineering from Institut Teknologi 10 November Surabaya, right? And I would like to brief shortly about the CV of Professor Moridi. It's look quite a lot of the publication, and also he has been published about the plenty books, yeah, all right, and also he joined a lot of research talking about the electrical. So he is now as a professor in Institut Teknologi 10 November Surabaya. So now, Professor Moridi, the floor is yours now, please.
Okay, thank you very much, moderator. Sorry, today is very busy for me. I just finished my lecture. Also, actually in Surabaya, especially in ITS, now is scheduled for COVID-19 vaccination.
Lockdown time.
Can you see my PowerPoint?
Yes, quite clear, Professor Purnomo.
Okay, thank you very much. maybe a little bit different with the topic, but I think this is also for industry. I think for hospital industry. Today, I want to talk about the utilizing IoT to design innovation based on human behavior in the education sector within COVID-19 pandemic. The outline of this topic, at first introduction, and then continue with existing IT solution for tackling COVID-19 pandemic, and then propose framework, discussion, conclusion, and the reference. As the introduction, I think we know until now is very rapid pandemic development. I think also in Jakarta right now is highest, I think, in Java. So the very rapid pandemic development actually spread all over in the world. And then until now, I think more than 1 year. So especially from India, there is new variant cases. So also many existing solutions, such like vaccine, lockdown, and protocol combined, also WFH. As you know, I'm from home. I'm work from home here. So the pre-existing IT solution include the big data, the COVID-19 prediction. We also work for the prediction, but actually we don't work in vaccine acceleration. But we work also in real-time alert generation. And then for high-performance computing, as well as complex scientific problem and process big data set in shorter time to develop new drug and vaccine. Also, we work in telehealth services, also diagnosis patient through video conference, I mean, also for tracking system. This is special in ITS. We buy a hospital mobilized robot. Actually, this robot is robot Iris that ITS team for the RoboCup robot. In this week, the RoboCup robot actually the house is France in the city Warju. So the Iris robot metamorphose has become Raisa. Also for the IoT, smart wearable devices in response to COVID-19 and early diagnosis. This is part of our research in ITS.
Excuse me, Professor Purnomo. Hello.
Sorry?
We haven't seen your slide, please.
Okay.
Yeah. No, no. The slide is on. He hasn't moving yet. The slide. I mean.
Oh, sorry.
So okay, okay, Prof. Okay.
This? Can you
Hang
see?
on.
Not yet.
Not yet. Not yet, Prof. That's better now, Prof. That's better.
Okay.
Yeah. Thank you.
Okay. From the beginning? No.
I think it's from the beginning. That.
Okay. Okay. Sorry.
That's all right. I think it's enough, Prof.
Okay. I will do manually.
Okay. Sorry.
This is the outline, and then shall we continue? This is the introduction about a very rapid pandemic development. And then this is the many solution. And then in this case, shall we continue? This is the pre-existing IT solution. We work in this place in robotic and also for IoT. This is part of hospital industry, I think, and part of industry 4.0. And then this is a network of the work that I have done. Some of this. So this is we include in machine learning, and then the data we get from social media, and then we build for the security system. Also, we include the data from the hospital. The other science, such like computer vision and visualization of the tool. About the IoT and COVID-19, actually in ITS, we have done for monitoring patient health with wireless wearable sensor in different scenarios and medical condition, such like early warning system and also digital contact tracing, and so on. Uh, in this case, IoT bring critical merits for COVID-19 pandemic, and also IoT is an innovative technology that could assist to track high risk patient, and IoT also adoption in various broad sector smart tool. So IoT COVID-19, such like this diagram, is very effective diagnosis, also in enhanced diagnosis. We also reduce chance of mistaken. I'm sorry, my PowerPoint is doesn't work well. So we have
That will be all right.
this is Iris as forerunner of the Raisha robot. This is our team. Sorry. Sorry, can you see this video?
Yes, the picture already there, but it's not moving yet.
Sorry, can you see this?
Yes, we
This
can
is
see.
the Raisa
Yeah.
robotic video.
Yeah.
Okay. This is trial the robot to the Erlangga University Hospital. Actually, this was done in Erlangga University Hospital. The robot task is for deliver the food for the patient. The task of the robot help the nurse to assist the nurse for patient. This is integration system using IoT on COVID. Sorry. Yeah, this is the integration our system using IoT on COVID-19, as well as this is the graphical of the tools for the prediction model, alert system, also for tracking, and also for monitoring. Uh, all of the system actually is online. So what the new data is processed parallelly. So we use share model for the system for COVID-19 prediction. And we use this model for ultra wideband localization. And then for monitoring system, this is also indoor setting, outdoor setting for monitoring. And then will result alert system. We use Google Fence API. This is our process purpose framework. So this is a share model in our system. So we don't talk about this formula. This is included in our system. Can you see the our model, share model? This is an illustration. This work well in our system, online system. This is the IoT tracking system as well in indoor setting or outdoor setting. Indoor setting, we use the UWB, ultra wideband localization. And then for the outdoor setting, we use the QFence API. And then this system, IoT tracking system, the illustration such like this. This is actually for alert system. So we use just like this block diagram. The alert system will receive from this UWB localization, integrate with indoor setting, outdoor setting for the COVID-19 monitoring system. So this is to monitor the integration system illustration. The system is online. This is our dashboard system. So this is the result of the COVID prediction. We use the share prediction, such like this. We have some district, sub-district in Erlangga, also in, this is like in Alun-Alun Contong, this is a part of region in Surabaya. So the model performs is based on lowest value of root mean square logarithmic error. So this is UWB performance our system. Here we included the power consumption condition. The red one is high power consumption. The yellow one, medium. This is the VLC. And then the green one, power consumption is low, as well as UWB, RFID, and also BLE. The system is high precision, also not susceptible to multipath propagation, also power saving transceiver. So in this caption, UWB, how does it works our system? The frequency of the system 3.1 to 10.6 gigahertz. The components as well as UW anchor, UWB tag, and also mobile application, show user location and place multimedia content. So the next is a QFence API. For example, this is someone from home and from for example, in the school, and then in the taxi or another place. The hardware include GPS, power, Wi-Fi, and the platform component, GPS location provider, and also network localization provider. Google API services, and this is the device using GPS. So this is illustration Geofence API. How does it works? The system. And then the next, the integration system performance measurement. In this case, the actor and user, smart device, and also real-time locating system service provider. This is the performance measurement and the tools, and also unit measurement. Okay, as the conclusion, this is a smart system IoT. There are some tools that can be useful to minimize severity of coronavirus pandemic, and then will impact in community. And we hope the proposed framework integrated system to suppress the spread of the COVID-19, to reduce the spread of the COVID-19, indoor also and outdoor. The integration system will trigger the alert system. The purpose is for human behavior tracking, the real time position. I think in our system, in security, privacy, also we include the ethic and digital gaps. So if we look for some drawback in instrument embedded in RLTS GPS, it takes quite time to be connect under bad weather condition, such like no in our place the internet is unstable. So I'm very sorry to because we are work from home. This is the reference that we use. Okay, thank you very much. That's all.
Okay, Professor Purnomo, thank you very much for your presentation. It's quite interesting and impressed for us, and I think it could be beneficial to human problem right now, and it's probably can as a result. I mean, as the research for the Indonesia, I think it's could be very good and very impress us. Thank you, Professor Purnomo. Okay, all the participant we have had already plenary, I mean, presentation time, which already deliver all the presentation article today from the three honors, our keynote speakers. Which is from the Professor Yul, Professor Changran, and Professor Purnomo. Now we will entering the Q&A session. I think some question would be addressed to the speakers. I think there's it see a lot of presentation. I mean, question. The first one, if I can, I think I don't know. It's Prof. Jul. Are you already joined now? Okay, now Professor Chang. Okay, Professor Chang Ren, Professor Jul.
Yes, yeah,
Okay,
yeah.
thank you, Prof. Thank you,
Okay.
Prof. Now, the first question is from Bulina. The question I think it could address to Professor Changren. The automation from dry field and wet field in Asian country is difficult. Could you explain about many obstacles in every stage of agricultural? And then also, which part is the most difficult among planting seed, fertilizer, weeds control, maturing of the product, harvesting and transport? And from Professor Franz, it could be I mean the same addressed to the second speakers, that Professor Chang, supply chain of the agricultural industry should expected place of the production of the dining table and was resources. I think it's not quite clear because there's some picture. Okay, and Professor Jewel, the one is the good. Yeah, I would like to ask about thermal and exergy efficient. Would you ask? Would you please, for example, of which one I should look for and on what occasion? It is from Animus, I think someone participant, and for the second speaker as well, from Tina Amran. Can you move to upward, please? Okay, Tina, that's one. Can we adopt the business model to other case in the agriculture? Thank you, Prof. I think that could be a 7 or 8 question first, and then afterward we can start it with another question. Okay. Who is?
Yeah, I think a lot of question is ask me.
Yeah. That's quite. I mean, interesting. I think Professor Chang then.
Yeah. So in Eastern Asia, the agriculture, they are facing the same problems. The land, agricultural land is getting declined because they overuse the chemical fertilizer, and there's because they want to increase the production, but the problem is the price is not so good because a lot of the agriculture products import from the United States and the European, which is the government supply a lot of subsidies. So they destroy the agriculture the industry in the Asia area. So in order to get it improve this, we have to think about to use the new way to do that. But lucky we have the Industry 4, we can share the information and we can integrate all the things together. So a lot of work doing. The most important is we should care about the green energy and the water resource. And this is not only not the single person farmer can do that. So we have to do is systematically. So automation is also one of the solutions for the modern industry. So a lot of things need to do. So I just point out how can we try the agriculture to the new agriculture the way in the future. So we cannot do no more the traditional way because it cannot supply enough food for the future. Okay, we were facing the shortage of the food. So we have to do right away. We have no time to waste. We have to do right away to transfer to the new way to do that. And the most important is circularity. Circular economic. We should make it work. This will help us make it stronger. Our supply chain. This is what I meant to hear. But a lot of problem. We can cooperate. We need to cooperate because Taiwanese company we have a lot of very good products. So it can help you to water saving and create a way to avoid the flooding problem because flooding would damage all the agricultural field. So this is kind of the we are facing already. IoT is must. We can help to enhance the whole system. I think that's just like to do that. Yeah, it's okay for everybody. Another thing, you can see my PowerPoint. And you can download my PowerPoint and a lot of material which I did not mention in the video. Yeah.
Okay. Is there any question?
Okay. Can I answer? Well,
Yes,
okay.
yes, please.
Okay. Right. The question for me is about thermal and exergy efficiency. Can I ask from example which should I look for? Normally we want to have exergy. Of course, some of the calculation what we normally for the system we go for thermal, but again that thermal efficiency is a total efficiency for the system, but because of our environment have a certain energy that cannot be tapped. Okay, it lost to the environment. That's why exergy is important also, because we want to know the availability of the energy for us to use. Right, that is what important for exergy. Okay, is it okay? The second one is I think about the application, right? Based on okay. Based on your research, PM is found to have more SG as well as entropy ratio. Is it radiation also higher? Yes, yeah, of course. If for they have a two, because this is interesting about porous media. You can have a surface flame and then what we call the submerged flame. I mean flameless. I mean when it's a submerged flame, then radiation is more. Radiation is very high. But when come to surface flame, just like a normal cooker, they have a radiation but slow, more convection is taking place. All right. Then one more. Okay, result of your research. Result of your research applied to household applications still have a large emission to produce a greenhouse. Yes, we still have higher, but if we can use a submerged flame, and then it's lower in terms of emission, it's lower. But if you use a surface flame is bigger, but we need to trademark lah because of the usage and also might be the application. Normally when submerged, we have radiation more, and then but in terms of application is limited. But when you have space flame, you have a more application, but more emission, and then also what we call it loss is there, is bigger also. That means we need a trademark in terms of usage, the fuel, and also on the emission side. Yeah, I think is it okay?
Think okay, Professor Joel. I think I found one question for Professor Heri Purnomo. Can smart IoT system produce an understanding of the interface between human behavior and sustainability during pandemic? Professor Heri
Okay.
Purnomo? Yeah.
Yeah, I will answer.
Thank you. Please.
Thank you very much, Helena, for the question. Right now, I am doing research about the collaboration between robot and human. So that collaboration, I think, is part of smart IoT. For example, in which place the robot will assist the elderly. For example, in the left side or right side of the elderly. So this is a part of understanding interfaces between human behavior and sustainability of the pandemic also. This is a part of our research about the collaboration between robot and human behavior. So I think, yeah, easily to understand for the robot the action of the human behavior. In this case, to assist the elderly.
Okay, that's all, Professor Purnomo.
Yeah.
Okay, thank you, Prof. Another question from Professor Franz, this addressed to Professor Changren. Supply chain of the agricultural industry should expand from the place of production to the dining table and the waste resources. Could you please explain this further?
Yeah, this is a must because we especially we are facing the COVID-19, and nobody go to the restaurant, and you can order from the internet, and all kinds of information in the internet, and so if you can provide the information, our product, agriculture product, is the low carbon footprint, then maybe the customer will think about this is good for the environment. They will purchase. This kind of the information will help the agriculture go transit to the new way to do that. And think about the farmer are facing the climate change. They are facing the product overproduction, and the needs of the is unbalanced. So they are facing the risk. But industry 4.0 will give enough information. Everything can be planned. Okay, you can plan how much product I need to supply to the customer needs. So the customer can order in pre-order. So therefore, we can have the link will help to make it stronger. So that's why this kind of business model is a very big opportunity. But we should work together to do that. And I mentioned the waste resource to make it another resource. This would make the farmer getting more profitable. So it was supposed to be willing to do the new sustainable way to do the new agriculture. So it will also good for the environment. So this kind of thing is linked together. Okay, is okay.
Is that
And
okay, Prof? Sorry.
how to maintain the water level, because you can measure the humidity. So we don't want to over irrigate the water. We can over irrigate enough water. So this kind of a tool, it is very useful. You can save a lot of the water resource. Okay.
All right. About Bolinar, is that all right? I think the last question, I think, yeah. Sorry, PMB is
Yeah,
sorry.
the green energy development is our in Taiwan. We are doing the green energy combined with the agriculture. This is the new trend to do that. And I want to mention this is very important. In the future, green energy is very cheap and decentralized. It would increase the agriculture system become sustainable. This is the approach we must do that. Okay.
Okay. Thank you, Professor Changran. And this one, I think, the last question for addressed to the Professor Jewel. PMB
Yes.
is the great innovation for the combustion resources. I
I
would
would
like
like.
to ask
Okay.
if PMB supported to be distributed massively.
Yes, because this PMB can be utilized so many things. All right. It is good because it's save a lot of fuel, because it can run at lean fuel. That mean fuel will be less be utilized during the combustion. That's why it is a great opportunity. And then only that, not all people are using that. They have normally for heating purposes, and also for might be for drying purposes they use PMB. Actually, it can be used in various way in future. But we need to have what we call it, whether is efficient or not is depend on the application itself. Right? I think I answer the question.
Okay. Thanks, Prof. Joel. The committee, could I have actually one question, if possible, to Professor Joel? Refer to your presentation, Professor Joel. You talk about the simulation, right, for the combustion.
Yeah,
How
correct.
can we prove that if we applied the simulation, it could be similar with the simulation? That's the one. The second is how if we use water or butane as a
Butane.
fuel. Yeah.
Yeah.
Thank you, Prof.
Okay. Actually, this is the most toughest parts lah. In during the combustion, simulation is very tough because it's involve chemical kinetics, right? Because of fuel combust, and then they have also many species in terms of emission, NOx there, CO there. They have CO2 is there. There are many species there. That's why it's very challenging, but still we can do that. But most of my students so far is not successfully simulate what we want lah. We still need to try. But some of the study are consider only a few species. Okay, for example, CO only or NOx only. That during the combustion should be okay in terms of simulation. But still, we cannot see the bigger picture. And then if come to 3D, especially for porous media, is very tough because porous pore is not uniform. They are mixed altogether. That is the toughest part. That's why still we need to find ways to do a proper simulation. Until now, we still struggling, Prof. That's why we are ongoing now. Even some students are run away to do a simulation. You don't want to do, right? Because it's tough. It take more longer time compared to experimental work. Yeah, that is the. And then butane is big because it's involved more carbon there, and then more hydrogen there. That we create more difficulty in terms of species. That's why it's tougher to put it more carbon kind of fuel. Better if we use methane or hydrogen, is much more easier. So hydrogen is no carbon there, is very, very good. But again, is to get hydrogen is very tough here in Malaysia. We easy to get a butane. Even methane also quite tough to get a small packet of butane. Yeah, that's why we use a butane. Butane easy to get from the shop only near our house. Right. That's why.
Okay. Thank you very much, Professor Joe. That's quite interesting, the answer. Okay, all the distinguished participants and also the honors three keynote speakers, our conference today, ICMIEE 2021. We ending the plenary session, but before we ending the plenary session, we would like to, sorry, before I talk this one, I mean, I would like to sorry to all the participant who is been asked the question, but it's not haven't answered yet. Probably we can pass to the keynote speakers by the communication by online. Probably we have next time their answer from the keynote speakers. Okay, and finally we finish the plenary session. But before we ending the session, we would like to pass the appreciate certificate of appreciation for the honors three keynote speakers today. I would like the first one to Professor Jule, please.
Okay. How? Okay.
Now, I think could MC or organizer pass the certificate? Could you
when through email or
through,
what? Wow.
no, I mean, I mean, we want to show you on the screen.
Oh, I
All
see.
right. Yeah.
All right. Okay.
But we will send it off to the email by email.
Okay.
All right.
All right. Thank you.
That's one certificate of appreciation for the Professor Jule. Thank you very much for you kindly delivered the talk today. And the second one to Professor Changren, please. Right, this one, Professor Changren, thank you very much also for you for the kindly presentation. I mean, delivered article for us to inspiring us. And then third one for the Professor Mauridi Heri Purnomo, please. Okay, Professor.
Okay, thank you very
Heri
much.
Purnomo, thank you very much, Pak. Sudah sibuk mengganggu kegiatannya. Mohon maaf. Semoga sukses selalu, insya Allah. Dan we hope the research is quite interesting to publish. Okay. Individually for myself, I would like to thanks to all of you, the honors of keynote speakers, our conference today, and also for all the participants which I mean stay with the session this session. So finally, I will hand it over the session to moderator. Thank you for the moderator. For the host, Haidaki and Olivia.
Okay, thank you, Mr. Erwin.
A farewell talk acknowledged by Professor Zulkifli, Professor. We would like to gratitude the honorable keynote speaker for all the hot topics.
And please
give a big applause to the moderator, Dr. Erwin, by guiding our keynote session today. And we would like to present the certificate for Dr. Erwin as a moderator. To the organizer. Okay, this is the certificate for Dr. Erwin for being a moderator today. Thank you, Dr. Erwin.
So much.
Okay, ladies and gentlemen, it was all the hot topics for today. And we would like to close the plenary session of International Conference on Mechanical, Industrial, and Electrical Engineering, or ICMIEE 2021. We'll have a lunch break until 30 GMT plus 7 before we continue the parallel session.
The first parallel session will be held at 1:15 p.m. GMT plus 7 or Jakarta time. Therefore, please be kind to join the room 15 minutes before the session or at 1 p.m. GMT plus 7 Jakarta time. And we would like to inform to all the presenters to kindly check the room at the program book which has been sent to your email.
Or you can also check the program book at the website icmiee.untar.ft.ic.id as shown in the chat room.
For the presenters who registered at ICMIEE Room 1, please do not leave this room due to the room that is going to be used will be the same.
For other presenters, you may leave the room and join the room provided in the program book for the parallel session.
Thank you very much for all the presenters and participants
for the participation and your attention.
Hasratku aku limpahkan, memuja keagunganmu demi bahagia di masa depan. Untukmu Indonesiaku, jiwaku aku teguhkan, menjaga kebesaranmu demi rakyatmu dan kemanusiaan. Untukmu Indonesiaku, karyaku aku ciptakan sebagai rasa syukurku kepadamu, junjunganku, oh Tuhan, sebagai rasa syukurku kepadamu, junjunganku, oh Tuhan.
Program Studi Teknik Mesin Jurusan Teknologi Industri Universitas Tarumanegara merupakan salah satu program studi unggulan di Universitas Tarumanegara. Didirikan pada tanggal 13 Agustus 1981 dengan menyelenggarakan pendidikan berdasarkan nilai-nilai integritas, profesionalisme, dan entrepreneurship. Memiliki visi menjadi program studi teknik mesin yang unggul dalam bidang teknopreneur yang memiliki integritas, profesional, dan berdaya saing global. Untuk menghasilkan lulusan dengan profil teknopreneur inovatif dan visioner melalui aplikasi ilmu-ilmu rekayasa pada perancangan mekanikal dan otomasi.
Gelar Sarjana Teknik Mesin Universitas Tarumanagara dapat diraih dalam waktu 4 tahun, terakreditasi A oleh BANPT dan juga oleh Indonesian Accreditation Board for Engineering Education, sehingga gelar sarjana Anda dapat diakui secara internasional. Kami melakukan pembelajaran bukan hanya dengan teori saja, namun juga dengan berbagai kegiatan praktik yang disusun untuk mengembangkan soft skills, leadership, dan pola pikir kreatif seperti proyek kelompok, magang, praktikum, proyek perancangan mesin yang dikombinasikan dengan berbagai kegiatan belajar lainnya, serta kegiatan kemahasiswaan. Pada kegiatan magang, Anda dapat menerapkan pengetahuan yang telah Anda peroleh ke dunia nyata, baik pada bidang industri dan pada bidang lainnya. Gelar Sarjana Teknik Mesin Untar memungkinkan Anda untuk berkarir di dalam maupun di luar negeri, baik pada bidang manufaktur, otomasi, otomotif, riset, oil and gas, serta sebagai teknopreneur. Program studi teknik mesin Untar terus berupaya untuk menghasilkan lulusan yang berjiwa teknopreneur, inovatif, visioner, dengan penuh integritas, serta mampu beradaptasi dengan perkembangan teknologi.
Untuk mencapai profil lulusan, program studi teknik mesin Universitas Tarumanagara memiliki 4 bidang keahlian, yaitu perancangan mekanikal dan otomasi, konversi energi, teknik manufaktur, dan teknologi material. Ditunjang dengan fasilitas yang memadai, program studi teknik mesin memiliki fasilitas seperti ruang kelas, perpustakaan dengan akses ke berbagai jurnal ilmiah, ruang diskusi, emergency exit, auditorium, ruang kegiatan mahasiswa.
Selama proses pembelajaran di teknik mesin Untar ini, saya mendapatkan banyak ilmu pengetahuan dan berbagai fasilitas yang lengkap, serta ada kegiatan workshop seperti go-kart dan mobil irit.
Program studi teknik mesin memiliki laboratorium, yaitu Laboratorium Proses Produksi, Laboratorium CNC, Laboratorium Mekatronika, Laboratorium Prestasi Mesin, Laboratorium Fenomena Dasar Mesin, Laboratorium Metalurgi Fisik, Laboratorium Hidrolik dan Pneumatik, Laboratorium Perpindahan Panas dan Massa, Laboratorium CAD/CAM, Laboratorium Teknik Tenaga Listrik,
Menjadi lulusan teknik mesin di Universitas Tarumanagara mampu membuat saya bekerja sesuai dengan passion saya. Bahkan saya mendapat pekerjaan pertama saya sebelum wisuda. Teknik mesin Universitas Tarumanagara memberikan kita peluang karir yang bagus, terutama di bidang industri-industri besar dan dalam waktu yang singkat. Pengetahuan yang saya dapatkan seperti perpindahan kalor dan massa, elemen mesin, serta berbagai kegiatan akademik dan kemahasiswaan mendukung pekerjaan saya saat ini sebagai seorang engineer.
Dibuktikan dengan rangkaian prestasi dosen dan mahasiswa berperan aktif dalam kejuaraan nasional dan internasional. Dosen program studi teknik mesin Universitas Tarumanagara juga aktif dalam melaksanakan tridharma perguruan tinggi, yaitu pengajaran, penelitian, dan pengabdian kepada masyarakat. Program studi teknik mesin juga memiliki beberapa kerjasama nasional dan internasional. Program studi teknik mesin Universitas Tarumanagara, creating innovative and professional mechanical engineers.
UNTAR, salah satu perguruan tinggi swasta terbaik di Indonesia, mengembangkan nilai-nilai integritas, profesionalisme, dan entrepreneurship. Lulusan UNTAR unggul berjiwa entrepreneur. Kalian ingin sukses? Mari bergabung bersama menjadi Untarian. Klik go.untar.ac.id, pendaftaran online dan real time. Menyediakan beasiswa penyelenggaraan pendidikan dan mahasiswa berprestasi. UNTAR untuk Indonesia, UNTAR selalu di hati.
Delivering small steps toward bigger dreams that become true. Inspired by Tarumanagara Kingdom, which prospered the people. As one of the oldest private universities, Universitas Tarumanagara has always forged the students. 8 faculties in Universitas Tarumanagara, with 29 study programs, including master and doctorate programs. We are ready to bolster the spirit to win the future that is getting tougher. We build today to win the future. Currently, Universitas Tarumanagara has more than 1,000 highly qualified lecturers who take part in forming students to have strong and positive nature. Untarian, to take the chance to work as a team, to take the risk for the greatest achievements and still respect others. To develop practical side of the knowledge with modern practical experience, making creativity an important role in creation and innovation. To create a generation of leaders with integrity, professionals with entrepreneurship spirit is our commitment. The future is yours to define. Universitas Tarumanagara.